Okay, so calculating volume, we're going to go through a series of examples, and we're going to do simple volumes for the simple shapes that we have in our formula sheet, not for all of them, just a few examples. And then we're going to go through some composition of shapes, just like we've done for surface area. The volume of a rectangular prism again, volume. Now, a general formula for a rectangular prism or for a prism in general, you take the area of the base and you times it by the height. But the area of the base, we're careful, it's an area of a two-dimensional shape. So depending what the base is, you got to calculate the area of that base. For some reason, sometimes it doesn't click. Students are taking the base as being 11, for example. Well, you need an area, so it can't just be a one linear unit. You have to have that multiplication for getting the area of the rectangle. So our area of the base is going to come from the base here. That's our base. So what's the area of that base? Is 6 from here and 11 from there. So width times length. Because it's a rectangle. And what's going to be the height? This is going to be the height. Therefore, the width is 6, the length is 11, and the height is 6 again. So 6 times 11 and times 6 again. $396 cubed. No, I have the notes in front of me. I'm not very good at mental math, to be honest, to do anything. I just can't focus. So all I do is doing on paper. So I could do like on paper 6 times 6, 36, and then multiply by 11. But you can do, this one can be done mentally. Like you just have to have focus. So 36, right, times 10, 360, right? And then you still have left 1 out of that 10, so 1 times another 36. So 360 plus 36, like 396. You can do that, but I'm not very good at it. The numbers get a bit more complex, I lose track. So for me, the on paper is way easier. Because that's usually where mental math comes from strategies that you learn to do on paper, long multiplications and all that, how you split up the numbers into units, tens, hundreds, right? All of those tools help you to do mental math in your head. But I'm no genius, I assure you. So let's keep going. But I'm flattered, of course. Having the volume of a cone. So for the cones, usually everything that involves a circle in a shape, you would have a particular formula, but it is kind of derived from this basis of the area of the base, times the height, but you have to divide it by 3 because it's actually a third of the cylinder that it came out of, right? So you don't have to memorize this. It's just kind of neat to know that's where it comes from. So the volume of the cylinder, you can look in your formula sheet, is 1/3 of what? Pi r square h, and then third is in front. You don't have to write it. You can write this one by ignoring the 1. It's the same thing as writing like this, or pi r square h divided by 3. It means the same thing, okay? And notice the base, area of the base is that circle base. Pi r square is the base, right? And the height, and divided by 3. What's the r? You have again the diameter. So 28, radius will be half of that, so 14. And we need the height. What's the height of the cone? 48. How come it's not 50? That's the slant, right? Okay, so you gotta remember that there are two different important parts of the cone. One is height, one is slant. They're both important when you have to do different things. So we have pi, we have 14 that we have to square it, and we have the height, which is 48, and we have to divide by 3. This calculation, because it has all multiplications and only division by 3, you don't need a bracket there. But if you think you might forget in other situations to put brackets around it, always separate with brackets the top and the bottom of a fraction calculation, division. And let's see what you're getting. Anyone that dares? Yeah, they want us to round the nearest, it says nearest centimeters cube, let's cross that off, nearest cubic unit. You don't need to convert, so just a cubic unit of the shape that you have. So we're gonna do to the nearest cubic unit is right there. So approximately 9,852 meters cubed. Does that mean we cannot convert? Yeah, we can convert. And I'll show you how to convert in lesson 3. How to get from cubic meters to cubic centimeters, for example. Volume of the pyramid in the picture. So the formula for the square base pyramid or other kind of basis pyramids, it's always going to be area of the base, in this case, the square times the height, and then divided by 3. Now, what's the area of the square? Well, we have the 25 by 25, so we know that. What's the height of the pyramid? We don't have it. That's right. We don't have it. So to get the height of the pyramid, that's right there in the middle. What we have to do is work again in that inside triangle. Remember, we worked on an inside triangle last class when we were looking for the slant, right? Now we're looking for the height. But we don't know it. Now let's take this inside triangle and make a drawing, a flat drawing, so we can see it better. That's the height. Now this is half of the 25. So 25 divided by 2 is 12.5. And this hypotenuse is given, right? It's 32. This H is standing for height, so don't confuse it with hypotenuse. Now, what can I use to calculate for the missing side of a right angle triangle? Pythagoras, right? So that can be A, this can be B, that can be C, right? Remember, C is always a hypotenuse, the longest side. So A and B, doesn't matter which one is which. Okay, so let's apply it. A squared plus B squared equals C squared. A is the one that I don't know. B is 12.5, let's square it. And C is 32, let's square it. So A squared is 32 squared minus 12.5 squared. A is square root of that. and that's the height. You can calculate it over here and get a decimal. Make sure you keep enough decimal points so you don't affect the final rounding. Or you can just leave it like this and plug it in into where you want it and just do the calculation all at once. It's really up to you. I think you now know how to use the calculator quite well, so you don't need to evaluate at this point, really. So now let's go back to the volume of the pyramid. It's 1/3 of the area of the base, which is the square. The square is 25 times 25, so that's the area of the square base. And then times the height, which is square root of 32 square minus 12.5 square. Let's see what you're getting. You should be getting, I'll tell you what you should be getting, and then you can check to see if you got the same thing. The decimal might be a little bit different because I use the approximated value here, but so this one is approximately 29.4575. You can use that as well. It's up to you, really. So, did you get it? Approximately equal to, let's round and get to the nearest unit, cubic unit, 6,137 cubic feet. Or like you can write it as feet cubed. You got it? No? How far are you on?
Do 25 times 25 divided by 3.
Yeah, we can do that.
Get like 208.33.
Sure.
I thought you were supposed to add them.
No.
Yeah, I didn't see this off there.
Okay, then. Solved, right? Composite shapes. The volume of composite shapes are pretty easy to do. Because even though some of them are overlapping, it doesn't really matter because the volume is still going to be the same, right? Either if you calculate them separately or together, they still take up same space, right, when you put them together. So the only thing we have to do as a plan, you have to calculate volume of this. This is actually a triangular base prism, right? Because it has two triangles onto which it can sit, top and bottom. It's just sideways sitting. So a triangular prism. And step 2, volume of rectangular prism, the box. And step 3 is just add them together, right? 1 plus 2. The only thing that might be sometimes difficult is with these triangular prisms. You gotta be careful when they're sitting sideways and you're looking at the formula for the prism. It says area of the base times the height. Is that true? When you're looking for the volume of the prism, for all prisms, right? Area of the base times the height. Now, what's the base of the prism? This is the base. That's the base. It's a triangle, okay? So you have to be visualizing your prisms the way we normally would draw them, okay? Like that, with the base at the bottom, right? When it's sideways like this, you might think the rectangle is the base, but it's not, okay? Now, if you want to apply the formula, okay? If you want to apply the formula, the base is always a triangle. So we need the area of the triangle, which is the base times the height of the triangle divided by 2, and times the height of the prism. So the base of the triangle is that one. What's the length of it? Yeah, the base of the triangle. 6. What's the height of the triangle? 4. What's the height of the prism? This one. 6. All we're gonna do is just plug in, right? So let's do the area of the triangle. Base is 6, height is 4 divided by 2, and the height of the prism, 6. You can do it all in one go like this. 6 times 4 times 6 divided by 2, right? What are we getting? This one? The H is the part of the formula. The formula for from here. This is the 6. That's the height of the prism. It's just the prism sits sideways. So your 6 is here, and then your base of 6 is there, and your height is right there, the 4. Upside down.
6 over 1.
To help you with the calculation, you can do 6 times 4 times 6 divided by 2. Any number can be written as a fraction as over 1. Not changing the answer. What you getting? 72. Right? If I say 3, that's 3. If I say 3 divided by 1, what is it? 3, that's right. So any number you can write as a fraction as doing it over 1. So 100 as a fraction is 100 over 1. But still equal 100. Okay? So when you need something as a fraction, then you just do it over 1 and you see the fraction in the calculation. Okay, so that's the area of, then the area we're doing the volume of the triangular prism. That was step number 1. The second step in our plan was the volume of the box at the bottom. That's the area of the base times the height for the volume. But this time the base is this blue part. This indeed now can be taken as the base. So it's a rectangle with dimensions 6 and 12. So area of the base is 6 times 12. What's going to be the height of the box? 4, that's right. So we need length is 12, width is 6, and height is 4. If you want to list them so you have them for later reference. $72 times 4, which is 288, right? total volume 72 plus 288, 360 cubic feet. So remember this, surface area of composite objects is always more difficult than the volume of composite objects, okay? These are pretty straightforward. All you gotta do is just see the objects, find the volume, add them up. But the surface area is different. It has overlaps, and you have to think about the overlaps. Coffee mug. Now, this one is an interesting one because the volume of the coffee mug is actually coming from looking at an entire cone where the bottom of the cone was removed, right? So we're asked, or it's telling us the coffee mug shaded in the diagram below is based on the cone with the bottom portion removed, determine the volume of the mug. So because the situation is a composite object, but by removing another thing, right? It's actually, when we were doing geometry, when I was learning this, we actually had a formula for that part as well. It's called a truncated cone, right? So it's a part of a cone. But the formula comes from this idea that we're doing together by removing the little cone from the top of the big cone. So if I calculate the volume of the entire thing, and then I focus on calculating the volume of the bottom one, to get this part, the shaded area, all I have to do is subtract them, right? Because I want to remove that to get my mug. Make sense? So if you want to put water in the cone, right? It's going to fill up the entire cone, the big cone, right? But if you want to only make a cup that's less than the bottom of that cone, right? You're going to have less water in it. How much less water? The volume of the bottom cone. Make sense? So the plan for this one is as follows. The volume of the large cone, volume of the mini cone, and step 3 is 1 minus 2. Volume of the large cone. Volume of the cone is the formula pi r squared h divided by 3. Let's use capitals for the large one. You can also write it as 1/3 times pi r squared h. The same thing. We need the r and we need the h. The radius for the large cone. That means the base of it is the circle right at the top. The radius is, not this bottom one, we're doing the big one. 4. Height is, for the large one again. No. This is the height. What is it? 24, that's right, because it's split up. The dimension is split up in 2. So you have one line segment there that says 12. Then you have another line segment there that says 12. So in total, you have a height of 24, right? That's right, the large one. No, this one. Yeah, that one. That's the large one. This is your large cone right there. See it? Yeah, okay, so now you have 12 and then 12 more. That's the height of it. Clear for everyone? Yeah, the larger is the big cone. Yeah, the big cone. So we have 24 there for the height. So equals pi times 4 squared times 24 divided by 3 equals. Uh, 402, yeah. 0.123, yeah. And then step 2, volume of the mini cone. Same formula, this is still a cone, but this time we're focusing on this cone right here. What's the radius of the mini cone? 2. What's the height of the mini cone? 12. So pi times 2 squared times 12 divided by 3 equals. Do you agree, Kemi?
Yes.
Yeah, sure. Whatevs. Like my kids, one of them, fine. Do this, fine. Go brush your teeth, fine. Sure is. Okay, so step number 3, to get the truncated piece of this that makes the cup, we have to take from the big cone, the small cone, and we're left with that volume. So volume, let's not call it total, volume left. That's left. Or volume cup, if you want. It's 402.1238 minus 50.2654 equals approximately 351.858. So approximately 351.9. Centimeters cubed. I'm assuming it's confirmed. You checked it. This is it. Yeah, 7:30. Cost problem is going to be next, so 7:45.